As we begin the plant layout design, notice that Solid Edge contains a complete list of translators, including popular DXF and DWG translators. In the AutoCAD Translation Wizard, we can set up and save different settings for specific styles of AutoCAD files. The preview window shows exactly how the file looks in AutoCAD. This interface also supports color 7 in AutoCAD, which changes from black to white depending on the background color setting. We can even zoom and pan around the drawing in the preview window. Solid Edge is the industry's best in translating AutoCAD data. Full control over layers is also provided. We can show or hide any of the layers as defined in AutoCAD and preview the results quickly. This level of support doesn't stop here. The Translation Wizard also gives us full control over the file units as well as the target drawing sheet size. Solid Edge also maps AutoCAD lines to the appropriate Solid Edge line type, so we'll have exactly the same lines after import. That same level of intelligence is carried through the colors as well, even for color 7, so we can continue to work on a black background but have black lines automatically change to white. The last few steps of the import wizard let us review the font and hatch style mapping to eliminate any font mismatching. Solid Edge includes fonts that match the most popular AutoCAD fonts. To get an idea of the intelligence of the Solid Edge import capabilities, let's quickly simulate an AutoCAD look and feel by changing the background to black. Notice how all the lines that were read as color 7 automatically invert from black to white. As we zoom in, notice how the integrity of the AutoCAD file was maintained in the translation to Solid Edge. Even the layers were maintained, and Solid Edge's Layers tab in the Edge bar makes managing these layers quite easy, like controlling their visibility. We can add, rename, or remove layers as needed, and just like in AutoCAD, set the active layer. Here we're going to select 3 layers and hide them. A common task in AutoCAD is to reuse data using blocks. Solid Edge has improved on that concept by allowing us to store blocks in a single file that better organizes our library and lets us share them faster. We can build up our libraries as we go, storing the block data in specific files on a central server. To make us more productive, Solid Edge ships with many of the most common blocks for electrical, piping, and mechanical use. The blocks are organized in easy-to-follow folders and library files. Here we're looking at a specific file that was saved with all the blocks that we need for our plant layout. Before we begin, we're just going to set up the option to maintain relationships, so as we drag these blocks in and create relationships, they will be maintained throughout the design. As we drag in this first block, notice that the color highlights in red to show us exactly where we are. Blocks can be dropped anywhere in the drawing and can be placed in precision by snapping to graphic key points such as endpoints, midpoints, centers, or aligned with any of these key points. The block attachment point to the cursor can be set by the user during the block creation. Once complete, the actual block displays with the appropriate color, hatching, line style, and so forth. Using the A and the S, we can rotate the blocks into position. And once again, picking up the endpoint of some existing lines, we can align and snap to specific edges. We can add as many blocks as we need, but in many cases it's faster and easier to pattern the existing data. Before patterning, though, we need to use the Smart Dimension to determine the distance we'll need between our pattern instances. In this case, 1.78 meters. And then we're going to change that dimension and place it on the dimensions layer. And in this case, the dimension layer is turned off, so the dimension will be hidden. During the patterning operation, notice the handy preview that shows us where the instances will be placed, and also notice how it updates and changes to the instances count or spacing. In this case, we're using a standard fixed pattern. However, Solid Edge also computes a pattern to fill a design area by finding the optimal instance count or adjusting the instance spacing. On this right side, we use 12 conveyors. As you can see on the left side, we only need about half as many conveyors. So it looks like the instance count we'll need is 6. So we're going to run the command again, and notice that we have a most recently used values field to make this go a little bit faster. In this case, we're going to place, again, the 6 blocks on the left. Now we're going to begin placing another conveyor horizontally. So we're just going to drag in another instance of that same block from the block library file. In this case, we don't need to do any rotation, and we're not going to lock to a specific key point. Next, we're going to add a turnabout. Notice the power of Solid Edge as we place this turnabout, in that we can align to specific key points in 2 different directions. So in this case, I want to line up to the midpoint on the horizontal conveyor and align to the midpoint of the vertical conveyor. And the dashed alignment indicators assist us in this process. As we finish up placing the last block for the 1.6 meter conveyor, notice the sheet tabs at the bottom of the drawing. Currently we're working on the 2D model sheet. This sheet is at 1:1 scale and mimics working in AutoCAD. If you're used to drawing geometry in full scale, you can still use that same approach in Solid Edge. While blocks are a productive way to go from nothing to something, Solid Edge also includes the most common drawing tools for lines, arcs, circles, and here what we're going to do is draw a rectangle with a simple drag approach to create a new size conveyor section. To better position the conveyor, we'll simply align its corner with an existing component. And because Siemens owns and develops the 2D parametric constraint solver, the rectangle retains its shape and connectivity and adjusts to fit with the other components. This new conveyor section is positioned correctly, but it's the wrong size. A smart dimension can be added to the lines, arcs, or circles and placed anywhere in the drawing. Dimensions can be added and adjusted to set the ideal size. Again, notice how the geometry updated to accommodate the dimension value. And as long as the geometry is not completely constrained, we can drag it where we need it. Any applied relationships will be maintained. Notice how we kept the alignment to the other conveyor sections. Now that main layout is complete, we're going to show off a little by adding some robotic arm blocks from some 3D models of these purchased robotic arms. Notice all of the detail in these components. While we could have drawn this from scratch, any drawing view from a 3D model can be converted to a block. This process takes data reuse to another level, as we can create sophisticated blocks directly from our 3D models. As we drag in more robots, notice that by simply clicking the S or the A on the keyboard, we can rotate the blocks about their origin to easily lock them into the position we need to suit our application. Within the last few minutes, we've imported a 2D AutoCAD floor plan and added a manufacturing line using predefined blocks and developed some new components with standard drawing commands. Some key tools in Solid Edge included the industry's best AutoCAD import translator, complete display control over layers, colors, block libraries, and alignment and snapping for precision placement. Many of these tools and workflows are available in 3D that let you take plant, equipment, layout, and design to the next level.